Thank you for the opportunity to be here. I am going to explain a little bit about the main idea behind the new projects in my lab. So I named this presentation as Exploring the Scoring Function Space for Structure-Based Drug Design. So in structure-based drug design, the main technique and the most used one is molecular docking. So usually in molecular docking, we have two tasks. The first one is to find the correct position of the ligand into a protein. And the second one is to predict the binding affinity between those two molecules. So what controls both of those tasks is a scoring function, is an equation. Every docking program have their own scoring function. They're very unique. So most scoring functions are very good at finding the correct position of the ligand, but they are not good at predicting the binding affinity. So this was our main goal, to get a new approach to get a better correlation to the binding affinity. So the main reason to why we think they are bad is because they are classical scoring functions. They are predetermined scoring functions made to work thinking about a diverse data set. So it's a data set of several proteins, and it was a scoring function made for that. So when we are studying a specific protein, usually this scoring function cannot work very well. So our proposal is that we should use a targeted scoring function. We should have a perfect scoring function just made for the protein we are studying. So how do we do a target scoring function? We usually explore the scoring function space. So in the field, we have a protein space, is an abstract space made with all the proteins. And we also have a chemical space with also an abstract space for all the chemicals. So we know that these spaces interact with each other with the protein ligand interaction. And our proposal is that we should have a scoring function space too, a mathematical space with all the scoring functions. So we believe that if you have a protein and the subsets of chemicals, we could find a perfect scoring function just to see the binding affinity of those interactions. So we propose to explore this space with the machine learning methods. My lab uses Sandris, is our program we made with 64 different machine learning methods just to explore this space. So to show how better the prediction can be with this approach, we tested it on CDK2. We used the program Molecular Virtual Docker that has 2 different scoring functions. And we docked 77 different ligands into this protein. All of these ligands, they are inhibitors. We already know the binding affinity, so we can compare in the end to the prediction, and we got them from the binding DB. So after docking, we use Sandris. So this program, we choose to have 6 features on our scoring function. So here are the features that we chose. It's interesting because all these features are actually from the classical scoring function from this docking program, and Sandris is going to use the methods to get the perfect weight for each feature to predict the binding affinity specifically for these interactions. So the results are here. This is just for the test set. It's 30% of the data that I showed. So here we have the classical scoring function MODOC from the program. This is the experimental binding affinity. With the first scoring function, we got a negative 0.05 of Spearman correlation. The second scoring function, we got a correlation of negative 0.3. And with Sandris, for this regression method, we got a correlation of 0.6. So this is our proposal, is that when you use a scoring function specifically made for the protein we are studying, we could get a better correlation compared to the ones that we already use on docking programs. So thank you for the attention. Sorry if I was a little fast. And on our website of my lab, you can get more details of all the projects that we have. So that was it. I'm open for questions.
Yes, but we still, some questions start to appear. How did you validate your scoring function? And the question from Kunal Roy.
So usually we actually validate it with the prediction of the binding affinity. We compare the Spearman correlations, the root mean square error, and the standard deviation we use. We also in the future are going to start using the AUC ROC curve for when we are studying to virtual screening. So for now, we are using the correlations to validate our scoring functions.
Yes, one more question from Pavel Polishuk. What kind of data you can use for model training? Only KI or others as well?
When we are developing the training set, we always choose one type of binding affinity. So this one is for specifically KY. So, but we also can do with IC50, but you have to have a whole training set just for IC50 and the test set also for just IC50. We also think KD also too. Basically, all the binding affinity, but you just have to be careful to just have this exclusive binding affinity on both training and test.
Yes, and the question from Hanoch Fenderovitz, what do you think would happen if you use your target's specific scoring function, not for a scoring, but also for red docking?
So that's the thing. Our scoring function was not made thinking about the redocking, because usually, as I said, docking are very good at finding the position. So it's not a problem that we need to correct. The problem is actually just the binding affinity. But in the future, we can improve our scoring function for doing the redock, but I really think we should have the AUC rock first before doing any redock or virtual screening.
Yeah, I don't see. Oh, one more question from Dmitry Shulga. How would you optimize target chem space scoring function? Or how would your optimized target chem space scoring function perform if applied to possible ligands dissimilar to the known ligands?
So yes, this is one of the projects in my PhD. What I want to do is use my scoring function to probably use for virtual screening to know new ligands for the protein. But again, I need to validate my scoring function first for virtual screening.
Yes, and the question from Vladimir Poroykov, is such approach based on the fitting to the particular target?
I don't understand fitting. Sorry.
No.
Based on the fitting. Do you mean how the protein will bind the ligands?
I think Vladimir means some particular protein or target in some particular protein.
Our scoring functions, they are very specific, so they usually work on just one protein, so they are based on the interaction contacts with the protein to its inhibitors. So I don't know if that was the question. Sorry.
Yes. Oh, from Walter Azevedo, it's not a question. Very nice talk. Congratulations. And from Pavel Polishuk, related to Dmitry's question, how do you define applicability domain of your models?
Applicability domain, I would say that, again, we are start first thing with testing this approach to the binding affinity, but our main goal is to use it for virtual screening and propose new ligands. I think that was the question.
Oh, okay. I don't see any other questions. Thank you for a nice talk.
Thank you.